today in the lab we're working again on the Amiga 4000D, and it's been a while since I've made a video on this computer. And that's because I've been having lots of problems with it. But I think I got most of those problems solved, and eventually I'll do a summary video of all of those problems. But today I want to continue on with my setup of this machine, and the next step that I have to do in the setup here is to get my hard drives all ready. And I figured while I was doing that, I might as well do some performance tests. For those that may not have watched the rest of the series, this Amiga has a CyberStormPPC accelerator in it. And on that accelerator is an ultra-wide SCSI controller, which is most likely the fastest SCSI controller available for any classic Amiga. Hooked up to this machine, I've got an external enclosure that has, at the moment, 3 Ultra320 SCSI drives in it. Now these Ultra320 SCSI drives are way faster than anything that was available at the time of release of the Amiga. In fact, these are actually not that obsolete. You can still buy them new old stock, and they were included in servers up to about the mid to early 2010s, was I think when these kind of went out of fashion completely. So they are way overpowered and will completely saturate the SCSI bus on the Amiga. So today we want to get things set up and do some tests to prove that. So to get acquainted with the environment here a little bit, I've got my compact flash to IDE adapter connected to the native Amiga IDE bus, and we've got a little workbench installed here on a partition called Recovery, and then another partition that has a bunch of tools on it. I found this setup really useful, especially when I don't have network connectivity, because I can take the compact flash card out, write files to it from my Linux machine, and have them available here. It is relatively slow, though. And so I also have left out on the desktop a couple of hard drive tools here, including the included with Amiga OS HD toolbox. Now this is normally in the recovery partition under tools, be right here, but I've left it out on the workbench for ease of access. Now HD toolbox is the standard partitioning tool, and it's what I use most of the time, but it's got its quirks, and chief among those are the fact that it can only operate on one interface at a time. So it can only operate on one SCSI controller or one IDE interface at a time, and which one it's operating on is set via tool type. So if you want to operate on a different SCSI controller, you have to come in here, edit the tool types, and set it here. So I have this set to cyberppc.device, which is my CyberStormPPC. If I wanted to edit the partitions on one of my IDE drives, I'd have to change this to scsi.device, which is, confusingly enough, the device name for the IDE adapter on the Amiga 4000. Blame Commodore for that. I don't know what they were thinking. Now the other problem that I have with HD Toolbox, and I've actually experienced this with most other partitioning tools, is that it doesn't know how to handle SCSI addresses larger than 7. Right? So, and that's not a problem on most SCSI interface cards because they're, or at least most SCSI interface cards for the Amiga, because most of them are narrow SCSI, which means you can hook up to 8 devices, including the controller, to the SCSI bus, and they're numbered 0 through 7. But this here on the CyberStormPPC is a wide SCSI controller. So one of the additions for wide SCSI was there's more SCSI addresses. They go from 0 to 15, meaning you can have a maximum of 16 devices, including the controller, on the SCSI bus. And HD Toolbox doesn't seem to handle those higher address numbers very well. Now, once things are partitioned, Amiga OS handles it fine, so it's definitely a bug in HD Toolbox, but it is annoying. So if we load up HD Toolbox here, we will see that I've got 3 SCSI devices, and these are my 3 Ultra320 SCSI drives here. They all have status of unknown, meaning they've never been partitioned before. I've wiped them before doing this video. And so let's lay down a partition on one of these. So the first thing we need to do is we need to set up the drive type. And we have to go in here and read the configuration from the drive and save it to the drive and this drive profile here. Now, why do you need to do that? Why doesn't HD Toolbox do it on its own? Well, that's another annoyance, because HD Toolbox is an old piece of software, and for very old non-SCSI drives, like the XT class drives that were the first hard drives available for the Amiga, at least directly from Commodore, you had to enter in all that data manually. But now that we've got that set, we can go in here to partition drive, and we can, edit and set up partitions. And so on each of these drives, I'm going to set up a pretty small, like less than a gigabyte initial partition. And I'm going to use this to do some file copy measurements and things like that. And so this drive happens to be a 34 gigabyte drive. So I'm going to name this partition C34 so that I remember which drive this goes to. I don't know how many Amiga users know this, but the DH0, that's completely arbitrary. You can put whatever you want into the partition name. Doesn't have to be DH0 or anything like that. And that can really help when you have a lot of partitions in different drives. You can figure out which ones they are. Alright, so I'm going to leave all the other options the same here because I'm just testing out the drive speed. And let's go on here to the next drive. So we got to do the same thing. Change drive type. I know that this is a different drive, so I have to define new. And then read configuration. It'll grab this all off the disk, and I'm already starting to see some problems. So I know that this is a 140 gigabyte drive, but this is only reporting 107 gigabytes. And if you know what you're looking at, you see the number of cylinders is 7. That's very low. But maybe this will be okay. Let's keep going here. So we go okay, and then now let's try and partition this drive. And we can see the partition screen is really wonky, like it won't let me define many partitions, and it's not started at the left edge. What's going on here? Well, on the Amiga, you define partitions in terms of number of cylinders. And if we look at the drive type that got read off of this drive, it only has 7 cylinders. So that doesn't give you a lot of flexibility in defining your partition types. What the heck is going on here? So in order to understand what's going on here, we need to understand a little bit about hard drives and some history here. And let's start with a term that's pretty essential here, which is a block. So a block is the smallest unit of data that can be stored or retrieved on a drive. And sometimes it's 512 bytes, sometimes it's 4096. The actual size doesn't matter, but what's important to understand is that a block is a distinct physical location on the actual surface of the spinning disk of the hard drive, right? And in order to be able to consistently get to that unique block, we have to have an addressing scheme. Just like how in order to find your house, the Postal Service, at least in the U.S., has assigned an address to every location. This is the same thing here. So there are 2 ways that hard drives get their addresses. Now let's start with the modern way first, because I think it makes a lot more sense. And that's called logical block addressing. And so this is where if you have a hard drive or a flash card or anything like that, and it has 1,000,000 blocks, then those blocks are just numbered sequentially from 0 to the high number, and you just say, give me block 100, and the drive gives you back block 100. You don't have to know anything about the physical properties of the drive. This is how modern hard drives work. This is how flash memory works. This is how all SCSI drives work, even the earliest ones. They all use logical block addressing. Now there is an alternate scheme that is really no longer used, and that's called cylinder head sector, right? And there, instead of just having a unique number that represents your block, you need to have three values in order to find your block. You need to know the cylinder number, which is here in yellow, and is essentially how far out from the center of the disk is the block. You need to know the head, which in the case of like a hard drive, you're going to have multiple spinning disks in here, so that's which disk it's on and which side, which corresponds to a read head. And then lastly, you're going to need to know the sector number, which is, from, if you think about this as like a clock face, does that mean your block is at 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, and so on and so forth. So with those three values, you can find any unique block on the disk. And very early hard drives that were not SCSI hard drives required this. So like XT class and early IDE ones. And so the computer actually had to know the physical properties of the disk in order to be able to tell the disk drive what block to get. Now we're dealing with modern SCSI drives here. So why in the heck do I have to deal with this in HD Toolbox? So back in HD Toolbox, you notice that when we read the drive configuration, we got a number of cylinders and a number of heads. And then blocks per cylinder is how many sectors there are per cylinder. And when we defined our partitions, you see they have a start cylinder and an end cylinder. Why is it that HD Toolbox uses this when I'm saying that modern drives use this logical block addressing? Well, and the reason for that is HD Toolbox is an old piece of software. And it was designed when Amiga OS had its first hard disks. And its first hard disks were not SCSI, they were XT drives. And so it had to incorporate all of this. Now, none of these values, cylinders or sectors or heads, make sense for a modern drive. But there are formulas that you can use to convert a logical block address into a CHS address and vice versa. And it's apparent that for whatever reason, that calculation failed when we were setting up this drive. Now, I've downloaded some other tools off of Aminet. One of them is something called Fix HDD Size, which purports to fix this issue, although it does not. But if we load this guy up, we can get a little bit more information about what's going on here. Right, so I'm directing this to look at my third unit of CyberStormPPC.device, which is the Seagate drive that's in question here. And it kind of walks through the calculations. So we see this drive has this many blocks, and it's roughly 140 gigabytes. But then this is where things go off the rails. Installed it as 7 cylinders with this many blocks, and that ends up being 127 gigabytes. And so we're losing a lot of data there. And it's supposed to be able to fix this, but this doesn't work. But it helps us understand what's going on here. We have a low number of cylinders with a high number of blocks, and the math just ain't mathing on how to convert these. Now, there are formulas out there where I could fill this in by hand if I needed to. But what I found instead is just using a different partitioning tool, in this case HD Install Tools, which I think originally came with the Octagon SCSI drives, although I'm not sure. Yeah, I'm not sure. But this tool has a lot more options, although it's still missing some newer options. But I can erase the partition table from this. And then I can set this drive up again. And this time, it has a more reasonable number of cylinders. It has over 500,000 cylinders rather than the 7 before. So this time the math is much better. For whatever reason, this HD Install Tools figures it out better. And if I save my changes to my drive here, I'm not going to reboot right now. But if I go back here to fix HDD size, I can see now that you know, the same. I have the same number of blocks because that's just the number of blocks it has. But I have more cylinders here with a different number of blocks each, and that maps out to exactly the number of megabytes that are on the disk. So this is a much better setup right now. I'm not losing any space for addressing problems. Now, because these cylinder head sector numbers are made up, there are going to be some cases where you have a drive, especially when it's like a flash drive that doesn't have any relationship to a spinning disk of magnetized iron, right? Where they're not going to be able to create a perfect calculation, and so you lose a few megabytes here and there. If it's a few megabytes, that's normal, but I was seeing much more being lost there. So this is much better. And now if I go back into HD Toolbox, my partitioning screen for this drive now works as normal. And so I can create a tiny little partition here and call it D140 for this drive. And I can hit save changes, and then when I reboot, my drives will show up. I'm going to go ahead and partition the next one here, and then we'll get to formatting them and doing a little test. Alright, so I've got my 3 drives all formatted, each with 1 partition, and I'm ready to do my tests here. So I'm going to do 3 different tests. The first is a pretty simple test using a command called drivespeed. And drivespeed, you can find it on Aminet. It just does a read test of the device. So here I'm testing my first IDE device. Remember, on the Amiga 4000D, the IDE adapter's device name is called SCSI device for some dumb reason. And we can see this reads at about 2.5 megabytes a second. So I'm going to do this test against all the drives, my IDE to compact flash adapter, and I also have an old IBM drive that used to be in this machine and is now in my Amiga 4000T, as well as a Zulu SCSI. Now that IBM drive and the Zulu SCSI are narrow SCSI drives, so they won't be able to take full advantage of the CyberStormPPC SCSI adapter, but I still want to see how they stack up. Next, I've got 2 different data sets here that I want to copy around and measure how long it takes to copy to various destinations. So I've got a set of System 7.5.3 disk images. These are Mac OS disk images I'm using for some emulation purposes. And each of these files is almost 2 megabytes, not quite. And there's a bunch of them. So it's a set of pretty large files for the Amiga. All told, they're about 22 megabytes, 23 megabytes, give or take. The other data set that I have is all of the Amiga OS 3.2 install artifacts and each of the updates to Amiga OS 3.2. This is a much larger set of files. This is close to 140 megabytes. And it's also different in that it has a lot of small files in it. It's a really varied set of files. You've got a bunch of ADFs, and then you've got a bunch of really small things like icons and text documents and things like that. Now, for both of these data sets, I'm going to be using a utility called Backup, which you can also get on Aminet. Nice little backup utility, but best thing here is that if I run a backup, like say copy this to this D36 here, it will tell me how long this backup took. And so I can use this to measure how long copies take. And for this one, we can see it took about 11 seconds, which really pretty good for that amount of data. This was about 25 megabytes of data or so. Now in that copy test, and actually in the drive speed test, I'm going to test 2 variations of that. Right? For SCSI devices, they can either be run in synchronous mode or asynchronous mode. Synchronous mode is faster, but it has problems with cabling, right? You can't have as long a cable in synchronous mode, and it's more susceptible to signal degradation. Asynchronous mode is slower, but you can run longer SCSI cables, and it's a bit more resilient. I want to see what the speed difference is between these two. Now, there's two different ways to set a drive into synchronous mode. The first way is through the RDB and settings in the partition table. And to do that, I use two different utilities. One is HD Install Tools, which is off of Aminet, and the other is HD Toolbox, which comes with Amiga OS 3.2. So for HD Install Tools, to turn on synchronous mode, when I go in here to set up the drive, there's a checkbox for synchronous. And we would save that to the drive. In addition, on new versions of Amiga OS, I don't think this used to exist, but you can set direct SCSI access through the advanced options here, this direct SCSI transfer. And this helps with synchronous mode, or so I've been told. So I generally set both of these. Now this direct SCSI transfer, I think you have to set per partition, which is a bit annoying, but it is what it is. The other way to set a drive into synchronous mode, at least on the CyberStormPPC, is to use the early boot up menu. So if we reboot the Amiga and hold down Escape, this is the early boot up menu for the CyberStormPPC. We can go in here into the SCSI menu, and we can select for each drive whether they're in synchronous mode, automatic detection, or in asynchronous mode. And this sets it for the whole drive at once. No need to futz around with the RDB. But this isn't available on every controller. This is something unique to the CyberStormPPC. So with that, I'm going to go do these tests, and then we'll look at the results. I don't have a spreadsheet program or a graphing program on the Amiga 4000 yet. But I do have one here on my Amiga 1000. I've got this program called Platinum Works, which I think was a fairly common Amiga productivity suite back in the 80s, and certainly in the Amiga OS 1.3 days. And I've got my results here in a couple of spreadsheets. Let's first look at this drive speed one. Now this is just a read test. It's not really real-world accurate. But I think there's some interesting results here. So higher is better, right? So the bigger the bar, the better the performance. And I tested out 6 different drives. So the first is the compact flash card connected to the compact flash 2 IDE adapter to the Amiga's native IDE interface. And that one doesn't have synchronous or asynchronous mode, so it's just kind of a baseline in all of these graphs, and it hovers at around 2.5 megabytes per second, which I think is probably the interface maximum for the built-in IDE adapter. Next, we've got 2 narrow SCSI drives, so we've got an IBM spinning drive and a Zulu SCSI drive. The Zulu SCSI is, of course, the SD to SCSI adapter, competes with the Blue SCSI. It's very popular right now, and is a good piece of kit. And then lastly, we've got my 3 Ultra320 drives here. I've got 3 that I was testing and that have different capacities, although I think they're all manufactured by Seagate. And I did this test where I compared asynchronous and synchronous, and then also setting that setting in the RDB versus the CyberStormPPC early boot up menu. And then auto is having the CyberStormPPC just set to auto detect, which seems in my case to always default to asynchronous. And here we can see that the difference in asynchronous mode really isn't that great. There is a performance improvement, but it's it's marginal at best. Whereas if we turn on synchronous mode, we either through the CyberStormPPC early boot up menu or by setting it in the RDB, these Ultra320 drives just blow everything else out of the water. I mean, it's amazing the performance difference. Now, I know these Ultra 320 drives can get a lot more than 30 megabytes per second, so this is probably hitting the interface maximum for the CyberStorm PPC. And this is about in line with what I'd expect. I've been told that the theoretical maximum for this variant of SCSI, right, which is the first version of wide SCSI, that's the variant that the CyberStorm PowerPC supports. The theoretical maximum there is around 40 megabytes a second, and we're seeing close to, if not exceeding slightly, 30 megabits a second. And so that's probably the interface maximum. And it's just, again, amazing the performance differential. And we'll see that in some of these other graphs, although not quite as dramatically as in this graph. So let's look at some of these other results. So first, let's look at the big file copy test. And so this one, I didn't do quite as many iterations. I did to the IDE drive from one of the SCSI drives. Then I did from the IDE drive to one of the SCSI drives. And then I did a copy between the two SCSI drives. I picked two at random to do the copy between. And I did this with both synchronous SCSI and asynchronous SCSI. And in this graph, smaller is better, right? And so in all of these, we can see that the synchronous copy, or having the drives in synchronous mode, makes the performance better. But it's not quite as pronounced here. But what we can tell is really that IDE is a big bottleneck. And so the highest copy that involved one of the IDE devices, so from one of the SCSI devices or to one of the SCSI devices from the IDE, is 22 seconds. Meanwhile, the SCSI to SCSI copy, which is still copying between two different drives, is 2 seconds. So that's a massive difference. And so it's still very clear in this picture that synchronous on the SCSI bus wins hands down. Now the last test is, I think, the one that might be closest to real-world use. And this is what I'm calling the complex test. And again, in this test, I was copying all of the Amiga OS artifacts, all the installation artifacts, which is a combination of a lot of big and little files, and there's thousands of them. And this graph is set up the same way, so the smaller number is better. And I did to the IDE adapter from one of the SCSI drives, from the IDE adapter to one of the SCSI drives, and then between two of the Ultra 320 drives. And here we can definitely still see that synchronous is better than asynchronous. And if you're on the SCSI bus doing copies between them, that still wins out. But the win here is not quite as large. Now I will say that it's interesting, copying to the IDE card, or the compact flash card that I have hooked up to the IDE adapter, takes a lot more time than copying from it. And I think this is related to just the way that flash media works, is generally faster at reading than it is at writing. So that's interesting. But then the SCSI to SCSI transfer, even though these are really fast drives, is still not that much faster. And I think in this case it's likely due to the fact that there's a bunch of small files, and so there's a lot more overhead in copying smaller files, or a lot of smaller files. There's a lot more operating systems calls. There's a lot more metadata that has to be managed. And so the bottleneck here is probably Amiga OS and the CPU, not the drives itself. So it's still a win. It's still much better performance. But it's not as dramatic as the other graphs. And so, kind of in summary, like, these are definitely some fast drives, but there are still some other bottlenecks in the system, and so I'm definitely going to see a great increase in performance. But we'll see on a day-to-day basis how much it actually matters, given that this is a very old system and that there's a lot of other bottlenecks in it. And I think this graph here is kind of the most relevant to day-to-day usage. So we're going to definitely get some improvements. We'll see as I use this and compare it to my other Amigas as to how good it is. Alright, well that is it for this video. Thank you all for watching. And I've got my hard disk now prepared for the next step in this journey, which is to get an operating system laid down and get all of this configured. So that'll be the next video in the series. Anyhow, again, thank you for watching. Hope this was informative or at least enjoyable, and we'll see you next time.